Okay, so today we're going to talk about adding and subtracting polynomials. This lesson is a little definition heavy, but it's pretty simple, so just follow along, take good notes, and you can use them like on your checks and quizzes and everything. Okay, a monomial is a number, variable, or the product of a number and one or more variables with whole number exponents. So just to give you an example, right, like a number, right, it could be 9, a variable could be x, or the product of a number or one or more variables, so it could be like 5x. So those are some examples, and they're also called terms. Okay, lighting. Okay, degree of a monomial. So the degree of a monomial is sum of all exponents of the variables in the monomial. Okay, so let's look at an example, right? We have 100. Our degree is 0, right? Because that's the same thing as writing like 100. 100 is the same thing as like 100 times x to the 0, right? Because this thing turns into 1. So this is our 0 right there. So if we have just a constant, the degree is 0. If we have, for example, 5m squared n squared, right, the sum of all the exponents, so this degree would be 4. If we had 10x cubed, our degree would be 3, right? And then finally, our final example, if we have 4ab cubed, the degree would be, this would be a 1 right there, right? A to the 1. So this degree would be 1 plus 3 is 4. Okay, a polynomial is a monomial or sum of monomials. Wow, I spelled that wrong. Monomials, each a term. So for example, like we could have 2x squared plus 4x plus 3. That's a polynomial. We could just have 4x. That's a monomial. We could have 5y to the 5th plus 3x to the 4th plus 7xy minus 4y, right? As long as you're adding monomials, adding or subtracting, that is a polynomial. Remember, poly means like many, right? Think of like polymer, which is like types of plastics, like mini plastics, or polyamorous, right? If you have like 2 boyfriends or 2 girlfriends. Okay, standard form. Standard form is really important. So a lot of these are vocab words, right? So you should be familiar with these. Standard form is written so that the exponents of a variable decrease from left to right. So for example, we could do like 3x cubed minus 4x plus 1, because it goes from 3 to 1 to 0. And then the coefficient of the first term is called the leading coefficient. So this is a vocab word, leading coefficient. So for here, the leading coefficient would be, right, 3. And then the degree of the polynomial is the greatest degree of its terms. So for this one, it would also be 3 because the greatest, right? We have 3, 1, and 0. So 3 is the greatest, so this one would be 3. All right, so lots of definitions. Let's do an example. Put in standard form, identify degree and leading coefficient of polynomial. So we're going to put it in standard form. So this is, right, this is degree 1, this is degree 2, this is degree 0, this is degree 3. So standard form, we got to go decreasing from left to right. So we're going to start with our highest, 4x cubed. Then we have the 2 term plus 3x squared minus 4x minus 2. Our leading coefficient, right? Coefficient of the first term. So the first term is right here, and that's the coefficient is the 4. And then the degree, right? The greatest degree of its term. So this is the greatest, is 3. Okay, so we have different polynomial names. So monomial means 1 term. Binomial means 2 terms. Trinomial means 3 terms. And these are all examples of polynomials, right? But this is just something more specific because we use them a lot. So instead of saying, like, binomial is very specific. And so when I want to be specific, I'll say binomial. So, right, an example of a monomial could be, you know, like n cubed. A binomial could be 12x minus 4. And a trinomial could be like 3x squared minus 2x plus 1. Or another example, right, we could have 2x plus 5, 2x squared plus 2x plus 5. Something to note, right, we need whole number exponents, right? So when we have whole number exponents, that means that we're not allowed to have like fractions, right? Like can't have x to the 1/2 or x to the 3/4 or like x to the -4, right? So can't have, so right, no fractions, no negatives. They need to be whole number exponents. Right, if you remember a whole number, oops, whole number is 0, 1, 2, 3, etc. Okay, so like I said, lots of definitions, going over terms or terminology, right? Because we're using terms as like a monomial. Okay, so the biggest thing is to be able to differentiate. So let's give some examples, right? Let's do 12x minus, sorry, we already did that. Let's just go to adding polynomials. Okay, so adding polynomials, we just need to add like terms. So there's 2 ways to do it. One, we could like draw lines, and the other one, we could like cross out what we've already done. So I'm going to write this problem twice, and you can just decide which method you like best. Okay, so the first one we're going to do, we're just going to cross out. So this one, right, we need to add like terms. And let's do a note over here, right? Right, big star. Like terms have the same variable to the same exponent. exponent. So this is really important, right? Okay, so let's look here, right? We have like terms. So here's an x cubed and an x cubed, so we're going to add them together. So 5 plus 3 is 8x cubed. We cross them out because we're done with them. Then we look for x squared. This is the only x squared, so we're going to do plus 2x squared. Cross it out. Now we're looking for x terms. We have a negative 3 and a positive 5, so we add them together. And we get plus 2x. Cross them out, and then finally we're left with plus 2. Another method that we can do is we can add lines. So that one has 3 lines because there's 3 x's. This has 1 line. This has 1 line. And then this has 2 lines because there's 2 x's. And so this sort of gives you like a visual, like, okay, I'm going to add these together. So 5 plus 3, we get 8x cubed. We only have 1 green, so plus 2x squared, right? It's plus. We have negative 3x plus 5x, so 2x. And then we're just left with that 2 at the end, right? And these are both the same. So this is just our adding polynomials. Another really important thing is, right? Pay attention. Don't confuse with multiply, right? This isn't saying, this is a plus sign, right? So even though there's parentheses, it doesn't mean you always multiply. It's just saying this term plus this, like this polynomial plus this polynomial. So don't try and multiply these together by adding exponents, right? Remember when we did the GEMDAS and you added exponents, or when you multiplied them, you added exponents, right? We had the GEM. Right, if I had 5x cubed times 3x3 plus 2x squared, we would add them, right? So this would be 15x to the 6th plus 10x to the 5th. There's nothing there, so that's multiplying, right? But if I have 5x cubed plus 3x cubed plus 2x squared, we're just adding like terms. So this would actually be 8x cubed plus 2x squared, right? So make sure you are not confusing multiplication with addition. You got to be very careful, right? This is multiplication, this is addition. So this unit is on adding and subtracting polynomials. So you shouldn't be multiplying at all, really. Actually, let me see. Yeah, I don't think so, unless there's a distributive somewhere else. But we shouldn't be confusing these two. So be very careful, right? Just because you see a parentheses doesn't mean you're automatically multiplying. You have to make sure that there's not a plus sign in between there. Okay, and then subtracting polynomials, you can distribute a -1 and then add like terms. So it's very, very similar. You just have to be very careful with the negative. All right, so I'm going to rewrite this. We have 6x to the 5th minus 3x. Minus minus becomes plus. Minus plus. So pretty much every sign in here, we're just switching. And now we can go back and we can combine like terms, right? So we have the 5s. So we have 6 plus 4 is 10x to the 5th. Negative 3x minus 2x is negative 5x. And then we're left with this plus 5, right? After we combine our like terms. Alright, almost done. We have another example. So for this one, I'm going to do the other method. I'm going to do the underlining one. So this is our 3. This is our 2. This is our 1. And then that one left over is 0. So make sure you don't forget about that. Alright, just be like, just circle it. Okay, so we combine our 3, so 5x cubed, and then this is a plus, so it'll be 6x cubed. Then we go with our blue, so we have negative 2x squared plus 5x squared, so that's plus 3x squared. Then we go with our greens, right, just our x's, our degree 1. We have negative 2. Remember this negative here, so minus 4, so negative 6 minus 8. we get negative 14. And then finally, we have our leftover plus 1, right? If we want to do it the other way, so we have 5x cubed minus 2x plus 1. And I'm just going to write it all. I'm going to distribute this one. So we have a negative 2x squared plus, whoops, that's a negative 4x. And then these are all pluses, so we keep them the same. X cubed plus 5x squared minus 8x. So we're going to check our 3's first, right? 6x cubed. Then our x squared, so minus 2x squared plus 5x. So plus 3x squared. Minus 2, minus 4, minus 8, negative 14x. And then finally our plus 1. Right. And eventually you don't have to scratch everything off or add these lines. You can do it in your head, but this just helps you keep track of everything so you don't make small mistakes. So as you do these more and practice more, you might be able to skip some of these, tricks, but you just need to make sure you get the final answer. All right, last two. So if I were you, I would pause the video and try these and then check and see if you got them right. I'm going to go ahead and do them right now. So we have 4m squared minus 3m. So we have m squared minus m plus 10m plus 9m, 2 plus 7 plus 9. And this one I'm going to distribute the negatives. So we have negative n squared plus 2n, and then this, the negative gets distributed. So we have negative 2n cubed. This becomes a positive. That's a negative. That's a negative. And so we have the 3. These two cancel, right? Negative n squared plus n squared just becomes 0. Then we have our degree 1, just the 1n. 2n minus n is n. And then minus 12. Right? So adding and subtracting polynomials is just like adding like terms. The tricky thing is you just have to be careful that you're making sure that you keep the degrees the same. So yeah, that's it.